We welcome Paul Woods and
Right.
Bob Milder.
Hi, I'm Paul Woods. I'm with Skytruth, and Ed Lorenzini was on the program, but he decided to send the guy that actually does the work. He's sitting over there. This is Bob. So I'm going to hand over to Bob. He's going to talk to you a little bit about the cool stuff they're doing at Analyze Corporation, and then I'm going to show you, hopefully, show you this demo of the technology we're working on right now with Google for some cool stuff we can do with the stuff that Analyze produces. So,
All right.
Bob.
I got that timer running, so I don't use more than my time here. I'm Bob Milder with Analyze, and this next slide there. So what we've been working on a project over roughly the last year, starting with taking the AIS data from SpaceQuest. We've been talking about a lot about AIS data. We've been adding some of this concept of motion behavior and algorithms to that data, and we like to work at Analyze. We like to work with the data, put the numbers together. We're not real big on the presentation and the visualizations of all that. We really like to focus on the algorithms. And we then pass all of the results that we're getting. In this particular case, we were looking for fishing off to Skytruth, and they've got a really cool visualization and demo that they're going to show you on what they've been doing with our data. Real fast, since we've been talking a lot about AIS, wasn't sure what everybody knows about it. I think so. The big thing I'll point out here, this is what an AIS satellite looks like. It's about the size of a basketball. It weighs 25 pounds. They're up there in a low Earth orbit, just sort of spinning around, collecting any of the AIS data from a vessel that has that on. We did get to see a picture earlier from Tony, showed where all the vessels are out there. When we look at what an AIS satellite is able to get, we get this picture of all these vessels out there on the sea, AIS being voluntary. Some of these vessels are telling us they're fishing. Some of them are not telling us they're fishing. What we wanted to do was we wanted to be able to identify fishing behavior using the machine, so that we don't have to take an analyst that looks at a track to figure out whether a vessel is or is not fishing, when they are or are not fishing, but we can use the machine to do all that. And you can see with all these vessels, they're all transmitting as much as frequently as every 6 seconds. You end up with a lot of data. It turns out to be a lot of dirty data, so it really is a big data problem. Our approach to this was we wanted to say if we're going to find fishing behavior, what I like to do is to really scale things back and look at what's the innate behavior of fishing. There's a lot of things that go on. There's a lot of different types of equipment. There's a lot of different motions. It's in a lot of different places. There's a lot of factors that can affect what fishing is. But we wanted to really start and take a step back and look at what is the basics of fishing. And it really turns out to be quite simple. It's we travel, we fish, and we travel back with our catch. Where we may offload it to if we're processing it at sea or we're transshipping. But there's still the economics behind fishing are we've got to get to the fishing grounds, we've got to pull the fish in, and then to offload all of that fish. So using that as our core, we said, okay, it's a big data problem. We've got to get the data so we can get AIS data. We're able to get 4 years worth of AIS data from SpaceQuest. We go back to 2009, so we can build a good historical base on what these vessels are doing from year to year to help design the patterns. As you all know, when you work with large amounts of data, the ETL problem is probably one of the biggest things that we fuss with. How do we get all this data manipulated so that we can actually use it and put it into a form where we can process it? Once we had all that loaded in, we looked at what are the different characteristics of fishing. We did quite a bit of machine learning to find out what are those characteristics that we had defined. Turned out to be the best characteristics, what were going to give us the best picture of fishing, and ultimately we created a fishing function. Just a quick idea, a couple of the fishing characteristics. We looked at just about anything we could come up with that might be something that would represent the motions of fishing. So we would take these features, and we had about 50 features that we came up with that we then whittled down to those that you'll see we use in our fishing function. So looking at things like your changes in vector heading during fishing, the idea of there's path efficiencies. So vessels, when they're traveling, a fishing vessel may have a slightly different efficiency than you take a cargo ship. So if you take a full pattern of a path, how might the fishing vessel differ from a cargo ship? We boil down. I thought I'd throw a little math up there just for fun. The important thing here that we're doing is we're looking at, for this particular pass, we're looking at the erratic motion and this concept of fishing vessels from an economic standpoint are acting erratically compared to other vessels that are out on the sea. So if you think of cargo ships. There are other vessels that act erratically, if you think about work boats, and some of these do in fact support fishing, and we'll see how those can tie in. For this pass, we use this characteristic of how close are we to land. We found that a lot of fishing tends to happen closer to land than out in the middle of the ocean. So we've got a point of land characteristic thrown in there, and then we threw in a navigational status. Since some vessels do tell us they're fishing, we wanted to say, if you're telling us that you're fishing and it looks like you're actually fishing, we'll probably give you a higher score for fishing than if you tell us you're fishing and you don't look like you're fishing, or you don't tell us you're fishing and you do look like you're fishing. So we try to mash all this together into our fishing function. And what we end up doing with that is we're then able to classify every AIS point with some type of a fishing or not fishing score. And this is what we end up feeding to Paul. So if we take with the AIS, and I'm not going to give you real pretty patterns. The important thing to remember with all this is that what we're doing is we're able to do this on all the vessels on the ocean very quickly so that we can identify those that are important to go look at. If a particular analyst would look at this, this happens to be coming off of the coast of Peru down in Antarctic. They're going out there. If you look at just this trail, you might say there's some interesting things going on over here. If you look at it real closely, looks like there might be some interesting thing going on there. If you were an analyst, you could zero in on that and you would see that there are some interesting things going on there, but you're not going to be able to do this for every vessel out there on the ocean. So we start to add our scores. Now we take this particular path, and for this pass we're looking at three colors: green meaning not fishing, blue meaning possibly in some type of erratic behavior that might be getting closer to fishing, red we felt was actually a fishing behavior, and if you go to pink, part of what we find is that there's a lot of work boats and other vessels that will act erratically also that are not fishing, so it's almost like you can go past fishing into the pink. So we're still tuning all this, but we see in fact that it looks like this particular vessel was doing some type of fishing activity here, probably a little less. We're going to zero in on this spot right here, because if you took just a quick look, you might see sort of the straight line through there. What we see is that down in that area, we start to see periods of activity that might in fact be fishing. When we zero all the way in on one, we now see that we do have a pattern of motion that in this particular case was determined that they were fishing at that location. So the whole concept being that we can take this, we can for every AIS point out there on the ocean for all the vessels, very quickly come up with some type of a weight as to whether that point in time they were acting in some type of fishing behavior. There's lots of uses for this, as you'll see when we pass it off to Skytruth, the cool things that they can do with it, their ability to present it to users so that users can start to do this. If you want to crowdsource, you have an ocean full of vessels, to be able to highlight those vessels that are doing something that might be fishing related at a particular point in time. It can be very interesting. So in conclusion, what we did find with this first pass on this program was that we were in fact able to identify vessels and their behaviors using AIS data. We're now in the process of taking this global. We did this in a small pilot area in the southern Pacific Ocean. We're going global with it, and we're starting to look at, because of the patterns we've seen, that there are going to be other things that we can identify. So we believe we'll be able to identify types of gear. We'll be able to, using the different behaviors of the vessels out there, things like transshipment and bunkering. With that, Paul, I'm going to give you plenty of time to talk about this.
Thank you. So, Skytruth, just a real quick what we are, and then I'll show you what we've been working on. So, Skytruth, we're a 501c3. We're a bunch of technologists in the DC area. We focus on remote sensing and software solutions for focusing on environmental issues. We've done a lot of work in the oil and gas industry. This is some analysis we did with synthetic aperture radar that was going off the coast of Nigeria. We've done a lot of those. We're pulling global data set from the VIIRS instrument on the Suomi platform that has a bunch of infrared bands on it, and with which you can detect natural gas flaring. And so that gets updated daily. And so we have a live map now that's fed with flaring detections we clustered over 30 days. We produced an interesting map that tracks the changes of that over time. We're also doing some crowdsourcing work. We're doing a project with Bloomberg School of Public Health. They wanted to know where all of the natural gas drilling, fracking related infrastructure was in the state of Pennsylvania for a public health study. But it turns out the state data is inadequate as to where everything is. So we need to get the satellite imagery to find out where it was, but there's a lot of places to look in Pennsylvania. If you want to find all the little storage ponds, there's a lot of them. So we rolled it out to the crowd, and we got several hundred volunteers to show up and take a little training and help us produce the data set, which we then validated with our interns in the office. So that's some of the stuff we've been working on. And now, see, now this is I didn't like it. I had to switch the monitor. So now we're just going to cross our fingers and hope. So, oh, there we go. Now it's going to load everything. We've been very fortunate at Skytruth for the last couple of years to be working with Pew and their program, Global Ocean Legacy Program, and working with Tony's group and focusing on this vessel tracking issue using remote sensing. And we've done a lot of work, looking at individual vessels and talking about what they're doing, and working directly with Pew and their partners. When we got a look at what Analyze was doing, we got to know SpaceQuest Analyze through that project. We started thinking about other stuff you could do with it, besides the kind of thing that Tony was just talking about. So instead of looking at what one vessel is doing and trying to say everything about what that one's doing, what if we looked at all of them and said, what are they all doing collectively? We've also been fortunate enough for the last couple of years to be working with Jennifer and her group, and Jennifer keeps inviting us back to great things like this. And so we got to know the Google engineers. And when I sat down with a couple of the engineers, I got like 2 circles and an arrow on the whiteboard, and they said, wow, that's great, let's do it. So we started doing it. So they promised me that we can scale this up to global scale, and we can serve it up to as many users as want to be able to see it. So this is what we're doing. So we take the data coming in from us. So you see that South America there. I got the nighttime view on here, but let's look at the daytime view. So this is a chunk of data that ran the SpaceQuest satellite data that ran through Analyze engine, and then they scored every piece of data there in terms of the probability that moment in time there was fishing behavior going on. So we loaded that all in here. We're using some cool tools that Kurt and Brian and his team are helping us with to visualize it. And one of the cool things that we can do is we can animate it. So, and this is a web browser. This is a regular web browser. You just open it up and it just happens. It's a lot of data, and the Google tools enable us to serve it up really quickly. So one of the cool things you can do is sort of have this heat map effect here, where so the bright yellow is high fishing score, the green is low fishing score. So you see a lot of vessels just transiting through, and so one of the things that it does is it lets you see the segment of the vessel's activity that was actually fishing. And then you can see when it started and when it stopped. And then the tool Tony was showing has a whole bunch of controls on it. We have 2. We have the date range. So this is now showing 16 days of activity all at once. So we can adjust that up to whatever we want to see. So now we start to get a heat map of where. If I just pause this, right? So now we're looking at 28 days ending on November in 2012. So we have the whole year of 2012 loaded up here. And so now you can see there's what fishing was, right? So this is a squid fleet off Peru. This is probably Jack Mackerel, but my tuna going on out here. And then if we zoom in on this thing, and then we can see all of the, there's the longliners. And if we narrow this back down a little bit, you can see where they're actually active, and then we can animate this. You can see how they're moving, and we can grab this time slider and just sort of move it around and see where everything is. So that's what we got working right now. This works on my laptop, and I'm glad it worked on my laptop. And we have just this data set in here. So, but of course, the obvious thing to do when you look at this is say, well, where's the rest of the world? And we're going to do that. So you're not identifying anything illegal here. You're not even identifying what the vessel is, right? You're looking at the aggregate picture of everything that's going on there. And then we envision that you can easily take a slice of this visualization as a picture of, for this area that I care about, here's all the fishing, and then once Analyze works their magic and figures out how to tell the difference between a purse seiner and a longliner and a trawler, then we'll color code by what kind of fishing it was. And possibly the heat map would represent vessel days of activity rather than, right now it's showing the likelihood that it's fishing, but we would change that, right, a couple of different visualizations. So that's what I want to show you. Do we have time? Yeah, okay, we got time. Questions?
Yeah, it seems like you just kind of mentioned it. It seems like there'd be three different behaviors to different kinds of fishing, from crab fishermen, long lines, nets, that kind of stuff. You might have to have different algorithms for each of those types of.
Yeah, that's exactly the plan.
That hasn't been the case yet.
So we found at the global scale that all the different types of fishermen still have sort of the same basic economic motivation. They are going to move different, and that's what we believe when we focus in a little bit more, that those sort of more specific movements will give us the different types of fishing. But I think the question you're asking is part of why this problem was viewed as very difficult to address, and I think some of what we were able to do was we sort of stepped back and said, instead of trying to figure out all those variables for all those different types of fishing, can we step back far enough and find sort of an innate set of variables that gives us a look at when somebody's fishing, knowing that then we can drill in further on the types of fishing. And as it turned out, and it's because Skytruth has been verifying with manually verifying these points that we're finding, that in fact we were able to sort of identify this innate concept of fishing.
How much are you able in both cases to validate what you're showing us, and like how much of this is pictures that are great, but you've actually done what researchers would have to do, and that is validate what you're seeing?
Yeah, we're working on that right now. We're developing a little tool to help us do that, where we'll pull out specific cases. And then one step is have an expert look at it and say, yep, that's fishing. We have right now a fellow who's worked as an observer on elastic fishing vessels, doing some ad hoc work like that for us to get a sort of a spot check, and then of course we hope to actually get a hold of real log data with some people who want to work with us on that. To really validate it. And then that feeds back into the model, and the model gets better.
And then for the AIS side, I'd recommend that you put an error model on top of what you're showing us, so that if you're going to present that as what you're saying is, you get a sense of how valid a point is.
I wanted to mention too, I just wanted to shout out to Russell over at the MPA Atlas, who this layer here, we just stuck that in yesterday because he just published it on Google Maps Engine, which made it available for us just to pull in as a layer. So thanks for doing that. Okay, back there.
As soon as Bob was point, we do a lot of AIS practitioner avoidance, and it turns out it's pretty easy to spoof your AIS position. So how do you deal with the parts leaking fishing? I would just spoof my position and speed to stay out somewhere else. So how do you deal with the concept, and how do you can you ground truth that?
You mean like that guy out there in Peru? Oops. Awesome. Yeah, we got one of those in this data set. Yeah, bad data. So he's actually fishing in the Andes someplace. Sorry, I lost him. Yeah. So how you deal with that is, well, so for people that are going to continuously broadcast bogus data, look at you. For someone who's turning it on and off, you can tell when that event happens. But for this kind of model where we're trying to get aggregate data, we're going to throw that stuff out, right? For enforcement-oriented stuff, that's a different problem. Talk to Tony because people have a whole bunch of ways to address those issues.
What's going to happen when they turn off their AIS? Everyone, the whole fleets are going to do that.
There's certainly a concept, and I'll speak on sort of behalf of SpaceQuest right now. So we're doing a big push with SpaceQuest to try and get 24/7 monitoring of AIS up there. Because now, even if we mandate AIS, as you say, if there's no way, if they know that it's not monitored, they're going to know when the satellite goes over. They'll figure that out pretty fast. They'll turn their AIS on when the satellite goes over. They'll turn their AIS off when it's not over top of them. So, I think that ultimately, if we can get the satellites up there, you can feel like everything else, it's a funding issue. We can get the satellites up there for 24/7. Then it makes it very easy from a policy standpoint to say, okay, now we can push that we mandate that everybody has AIS and has it on. Well, then with the 24/7 monitoring, now if somebody turns it off, there's going to have to be a policy for what types of organizations deal with it, but it can be flagged that somebody has suddenly turned it off, and maybe it's if you're out fishing and you turn your AIS off, now when you come into port, you don't get to sell your product.
The AIS obviously relies on that GPS position. So if you give the GPS position, which is simulated the whole time, there's no turning on, turning off, it's just something that's accurate. And as soon as you slow down, the simulated vessel carries on and turns around and comes back. So it is really easy to simulate your entire track 24/7.
It is certainly not.
I don't think I add. The point is, everyone talks about systems like AIS, or they put names on stuff, the company names even, and it's what you've got to talk about is what you're trying to do. So if we know we can track vessels using AIS, then people can now start to draw the positives from that. So like Fish 2.0, the traceability side of things, you can ask people to prove where they've been. There's no excuse for them to say, oh, my data failed, I don't know where I quite went. Seemed to go off when I got close to the EEZ, and turn the burden onto them to prove where they've been, which will stop them turning it off. And it's not just AIS, because you've got VMS like Trackwell. This is a safety of life at sea system, not a fisheries management system. It's just that we can manipulate it because it's open. So we've got to reverse the burden back on the fishermen to prove where they've been. And the question is a circular spiral one that goes like this. You answer one question, you take a step back, you go take two more forward, you go a step back, and we've just got to start to change the game. It's not going to be overnight, but this sort of technology will allow us to prove to people that they can be good actors, as well as just using it for enforcement reasons and trying to chase bad actors.
So this is a really good point to go into the coffee break where everybody can discuss this. So right now, break.
Break.
Thank you.